characteristics of an algorithm. Then one characteristic feature is unambiguous. Then that we can define as it should be clear, and unambiguous meaning it's a terminology used, and that means it should be clear, right? Clear and clear for the processing. Each of its steps or phases and their inputs and outputs should be clear and must lead to one meaning, right? Then should have an input. 0 or more well-defined input should be there. Then there should be an output of the algorithm, and the output should be one or more well-defined outputs, and should be the output should fit the desired output. Then the next feature is fitness. It must terminate after a finite number of steps. Then feasibility should be there. It should be feasible with the available resources. Then independent. It should have step-by-step directions, which should be independent of any programming code. And those are the characteristics of an algorithm. Then next thing, how to write an algorithm, right? We have already discussed about, we have started discussing about the algorithms. Then we have considered about what is an algorithm, then characteristics of an algorithm. Then the next task is how to write an algorithm. And considering the writing of algorithms, there are no well-defined standards for writing algorithms. That means you can find way of writing, but it should not be in an ad hoc manner. Then it is problem and resource dependent. They are never required to support a particular programming language. Then these are the things which you have to consider when writing an algorithm. Then we'll next move on to we'll take an example, right? This is the example. The example is design an algorithm to add two numbers and display the result. Do you need some extra, before starting that, do you need some extra time to take down the things? Can you hear me? Hello? Right. Then anyway, after finishing the entire presentation, not today itself, but I will give you the presentation, right? Then therefore, if you have the capacity, you can take down it in some form, in electronic or written form. Then we'll again come back to this session, that is design an algorithm to add two numbers and display the result. Then usually we consider this step 1, 2, 3, 7 up to 7, but the writing this step numbers is optional. The requirement is you have to brief the procedure, right? If you apply step 1, step 7 likewise, then it will be much more clear. The first thing is start, right? Start, then declare the three integers as A, B, and C. If we consider a programming language, this is declaring variables, right? Then remember that this algorithm is not written for a particular programming language. Therefore, we can call it as declare three integer numbers as A, B, and C, right? Then define the values of A and B. In that case, you have to initialize the variable values A and B. Then after that, add the two values A and B. Then store the output of step 4 to C. C is used to store the resulting value. Then C is used to store the step 4's resulting values. Then print the C. Then after that, finish. And that is given using stop. Right? That's how we can write an algorithm. Then in addition to this previous way, we can use this alternative way of writing the algorithm. Then in that alternative way, we can say start at, then get values of the A and B. Then C will get A plus B, then display the C, then stop. That's why I told you that there is no specific way of writing an algorithm, but always there should be the way of reaching the target output in a step by step manner, right? Then I'll give you a sample problem. This problem is given a list of positive numbers. Return the largest number on the list, right? Then is there a way of writing this algorithm? Can someone explain how to write it?
We can, first of all, we can select two numbers.
After that?
We have to choose the largest number from that two. Number. After that, again, we have to take another number from the our number set and check the other one. In that case, we can select the next largest number and again take one number from the other set, and as just like that, we can select the largest number.
Right. It's correct up to some extent. In this problem, actually, we are considering about a list, right? Then we can't decide which number is the largest number, right? Therefore, we have to first initialize the one number to as the largest one, right? Then after that, we have to compare the selected number with each and every number in the list, right? Then we'll see how we can do it. Then same as in the previous examples, we'll start with the start. Then here we are dealing with the list. Therefore, we'll set, if it's a list, then you have to imagine a data structure like an array, right? Array is a data structure, but we'll learn more about arrays in next lessons. Then by considering that, we have to set the maximum value to 0, right? 0th position is the starting position of an array. Then for each number, then in the X, some people are waiting in this room, right? Always I have to, then, right, then for each number, X in the list, each number here we consider as the X and the list is considered as the L. Then compare it to max. Now what is the value of the max? Tell me what is the which value we are taking using the max? Maximum is considered as the 0th position. Then we we check X as the larger one and set the max to X, right? That means what? X is larger than the 0th position, right? Then set max to X. Then max is now set to the largest number in the list. Then continue this process, right, until the end of the list. That is not included here, right? But you have to continue the process. Then finally continue the step 3 and 4, right? That has to be included here, right? Continue the step 3 and 4 under number 5. Then finally print what? Finally print the max or display the max, then stop. And those are the required steps to solve this problem. If you have any questions, then you can ask about this. I can't hear any voices. Time to time I could hear. Is there someone speaking anyway? I can't listen to you properly. Anyway, I hope you have understood this. Those are the fundamentals about the algorithms. Then we'll consider about the important categories of algorithms. Right? If we categorize the algorithms, then we can write algorithms for search, then sort, insert, update, delete. Right? Why do we use the search? Why do we use the search?
To find some information quickly.
Yes, find an information. It can be a value or it can be a character value or a numeric value. Right? If we consider about an array, to find a value or a string character value can be. Then sort. Why do we use the sort?
To order data.
Yes, to order data in ascending or descending order. Then insert. Insert is used to insert an element or a data to a data structure. Then update. What is the difference between an update and the insert?
Inserting new data. Update means doing some changes to the data which already inside the database.
Right, very good. Insert is always adding a new data to the data structure. Update is always dealing with changing and existing data in the data structure. Then delete. Delete is to delete an existing item from the data structure, right? Then the deleting will remove an element from the data structure. Those are the categorizations of the algorithms. Right, then we can consider about the efficiency of an algorithm. Efficiency can be analyzed at two different stages. One is before the implementation, other one is after the implementation. Right, before implementation means, implement means executing the algorithm. After implementation is efficiency is taken after the execution. Before implementation is the efficiency is taken before implementing the algorithm. Now we can consider about this priori analysis. It is a theoretical analysis about algorithms. In this method, efficiency is measured assuming that all other factors, as an example, processor speed, are constant and have no effect on the implementation. My priori analysis is based on maintaining constant structures about the physical resources. Then the next analysis is all analysis are used for analyzing the efficiency. Posterior analysis is an empirical analysis, and the selected algorithm is implemented using a programming language. Then this is executed on the target computer machine. Actual statistics like running time and space required are collected. Using the posterior analysis, we collect the running time and the space required to measure the efficiency. Then we can consider about the factors which will decide the efficiency of an algorithm. One is the time factor, the other one is the space factor. If we take the time factor, this is measured by counting the number of key operations. As an example, comparisons in the sorting algorithm. When we consider the time factor, we are measuring counting the number of key operations of the algorithm. Then the space factor, then using the space factor, we measure the counting the maximum memory space required by the algorithm. These are the factors which will define the efficiency of the algorithm. We'll consider about the complexity of an algorithm. This is measured using Fn. Then it gives the running time or the storage space required by the algorithm in terms of n as the size of the input data. Right? This is a little bit mathematical oriented, but to give you the basic understanding, I will give you how to measure the complexity of an algorithm. Then if we consider the space complexity, it represents the amount of memory space. Now the time limitation was given. Anyway, if you can hear, then I'll continue from this complexity. Right, if we consider the space complexity, it will represent the amount of memory space required by the algorithm in its life cycle. The space required by an algorithm is equal to the sum of the following two components. One is the fixed part, that is space required to store certain data and variables. This will be independent of the size of the problem. As an example, simple variables, constants used will be considered in the program size. Second one is a variable part. This is not about declaring data. Variable part means there's a variation. Variable part is a space required by the variables whose size depends on the size of the problem. Right? If we take the variable, then it's having a type. Then depending on that, we'll consider the space. For example, dynamic memory allocation, recursion stack space, etc. Right? Then space complexity can be given using the SP of for any algorithm. Then P is SP equals C plus SP. Within brackets, we can say L. C is the fixed part and SL is the variable part of the algorithm. Then this will depend on the instance characteristics of L. Right? Then the time complexity. It will represent the amount of time required by the algorithm to run completely. This can be defined as a numerical function Tn, where Tn can be measured as the number of steps provided. Each step consumes constant time. As an example, yes, then there are n number of steps. Consequently, the total computational time is given using Tn equals C into n. Then C is the time taken for the addition of 2 bits. Then we observe that Tn grows linearly as the input size increases. Right. Then asymptotic analysis we'll consider next day. Right. Then the mathematical side I am not going to discuss with you in much more deep manner, but you should have the basic understanding of this calculating the complexity and efficiency. Calculating the complexity of the algorithms. Right? Then if you have any questions, you can raise now, or else we'll meet next day. I will inform you the next day in next week. Hello?
Yes, miss.
No. All right. Right. If you have any questions, you can ask. No need of asking about the mathematical side in a deep manner, but if you are interested about this, you can refer to the books which are available in the library or ebooks which are available in the internet. Right. Then we'll stop the meeting for today, right?
Okay, miss. Thank you so much.
Okay. Bye.